A person with a receiver, a person with a receiver 5 kilometers away from the transmitter, 5 kilometers away from the transmitter. What is the distance that this person must move further? What is the distance that this person must move further to detect a 3 dB decrease in signal strength. So options are: option A 942 meters, option B 2070 meters, option C 4978 meters, option D 5320 meters. So this is a given question. The solution to this question is, first of all, analyze the question. A person with a receiver 5 kilometers away from the transmitter. That is, suppose this is a transmitter point. So a person is here. He have a receiver in his hand at 5 kilometers. The distance between these two is 5 kilometers. So the distance is 5 kilometers. What is the distance that this person must move? What is the distance this person must move further to detect a 3 dB decrease in signal strength? A 3 dB decrease in signal strength. So he has to move some distance so that the signal strength will decrease by 3 dB comparing to the person at this particular place. So the person is suppose here with the receiver in his hand. So now here the signal strength is 3 dB lower when comparing with the person is at this particular position. So the total distance is, I am considering from transmitter, is x. So this is x minus 5. The distance is x minus 5. Suppose at this particular place the power received is PR1. So at this particular place the power received is PR2. We know that based on Friis transmission equation, based on Friis transmission equation, we know that what is power received? Power received is equal to power transmitted into lambda by 4 pi r whole square into directive gain of transmitter into directive gain of receiver. Here the relations are with respect to only distance. So how we can relate power received and with respect to distance? There implies power received is inversely proportional to 1 by r square. Power received is 1 by r square. Now suppose power at first point is P. Power at first point is P. Now he has to move some distance such that the signal strength, suppose signal strength is decreased by 3 dB. 3 dB means 1 by root 2. 1 by root 2 decrease. So then power how much it decreases? Power PR2 is equal to P by 2 because E square. Because of E square. Power received is nothing but E square by some 2 eta. So if you at first point power is P, then at second point the power must be P by 2. So P by 2, then only there is a decrease in 3 dB of signal strength. So the power received at the second point is P by 2. We have to calculate the distance. So power received by PR1 by PR2 is from the transmitter. The first distance is 5 kilometers. This is inversely proportional to R square. This is nothing but R2 square by R1 square. R2 square by R1 square. Therefore, power received 1 P by power received 2 P by 2 is equal to R2 is X from the transmitter. Remember, from the transmitter side you have to calculate the distance. X by R1 is 5 whole square implies X is equal to how much? X is equal to 50. X square is equal to 25 into 2, 50. X is equal to square root of 50. X is equal to square root of 50 kilometers. Square root of 50 kilometers. So this is how much? 7.071 kilometers. Nothing but 7071 otherwise 7.01 kilometers. X is equal to 7.01 kilometers. But he has to move a distance of x minus 5. What is the distance? What is the distance between first point and second point? X minus 5. X minus 5 kilometers. Therefore, x minus 5 means x minus 5 is equal to 7.071 minus 5 kilometers. That is 2.071 kilometers. That is equal to 2071 meters. So the distance between first point and the second point is 2071 meters. 2071 meters. 2071 meters. So how much distance he has to move from first point? So he has to move a distance of 2.071 kilometers or 207 meters from first point to detect a signal strength lower than 3 dB from the first point. So which option is correct? Option B is correct. Option B is correct. So this kind of problems are very interesting. So you have to apply your basic knowledge on to solve this type of questions. Next problem is problem number 7. A transmitting antenna radiates 251 watts isotropically. A receiving antenna located 100 meters away from the transmitting antenna has an effective aperture of 500 centimeters square. The total power received by the antenna is options are option A 10 microwatt, option B 1 microwatt, option C 20 microwatt, option D 100 microwatt. So this is the question. So the solution to this question is, first of all, write down what is the given parameter. So here a transmitting antenna radiates 251 watts isotropically. So what is the transmitted power? PT, transmitted power 251 watts isotropically. Here this meaning, this sentence has some meaning. So isotropically means, what is the directive gain of transmitter? 1. Directive gain of the transmitter is 1, because for an isotropic radiator we know that directive gain is unity. So here indirectly they given that the directive gain is 1 for transmitting antenna. A receiving antenna located 100 meters away from the transmitting antenna. So this is a transmitter. So this is a receiver. The distance is 100 meters. The distance is 100 meters. So R is equal to 100 meters away from the transmitting antenna, has an effective aperture of 500 centimeters square. That is AER. Given AER. So AER is equal to 500 centimeters square. Then the total power received by the antenna is. Then they are asking, what is the total power received? PR. They are asking, what is the total power received? Here we know that total power received is equal to, according by using Friis transmission equation. So based on Friis transmission equation, we know that PR is equal to dZt into dZr into lambda by 4 pi r whole square into power transmitted. So here we know that PT is known, dZt is known, AER is given. So we have to calculate dZr. But we know that what is effective area? Effective area of any antenna is A is equal to lambda by or A is equal to lambda square by 4 pi into directive gain. So here AER, effective aperture of receiving antenna, is equal to lambda square by 4 pi into dZr, implies dZr is equal to AER into 4 pi by lambda square, 4 pi by lambda square. So substitute the value. So dZr also we know, AER is known, 4 pi is known, lambda square. So keep lambda square as it is. So if you substitute all the values, so therefore power received is equal to dZt is 1, dZr is AER into 4 pi by lambda square into, this is lambda square by 4 pi whole square into r square into power transmitted. So lambda square cancels, 4 pi cancels. So the remaining is AER into power transmitted by 4 pi r square. Therefore power transmitted is equal to AER. AER is 500 centimeters square. So convert into meters. So 500 into 10 power minus 2 meters. Centimeter square means 10 power minus 4. 10 power centimeter square. So 10 power minus 4 meters. So this is AER into power transmitted 251 watts. Total divided by 4 pi into 100 square, because R is equal to 100 meters. So if you calculate this, you will get 99.86 microwatts. 99.86 microwatts. So if you compare the answers, this is approximately equal to 99.86 means approximately equal to 100 watts. So if you compare the answers, option D has 100 microwatts. 100 microwatts. So option D is correct. Option D is correct. So here nothing is there. So just to relate unknown things in terms of known things by using known formulas. So this type of questions are very important. Next problem is Problem number 8. A 1 kilometer long microwave link uses two antennas, each having 30 dB gain. Each having 30 dB gain. If the power transmitted by one antenna is 1 watt, the power transmitted by one antenna is 1 watt at 3 gigahertz. The power received by the antenna is option A 98.6 microwatt, option B 76.8 microwatt, option C 63.4 microwatt, option D 55.2 microwatt. This is another problem. So the solution to this problem is, first of all, write down what is the given thing. So a 1 kilometer long. So microwave link uses two antennas each having 30 dB gain. So this is a 1 kilometer microwave link. One is the transmitting antenna, one is the receiving antenna. The distance is 1 kilometer. So R is equal to 1 kilometer. So what is the gain of the two antennas? So DZT is equal to 30 dB. DZR is equal to 30 dB. The power transmitted by one antenna is 1 watt. So PT is equal to 1 watt at 3 gigahertz. So F is equal to 3 gigahertz. So the power received by the antenna is, so power received, that is what is the power received by the antenna, PR. So by using Friis equation, Friis transmission equation, what is the relation? PR is equal to directive gain of transmitter, directive gain of receiver, lambda by 4 pi r whole square into power transmitted. Here lambda is indirectly they mentioned, lambda is equal to C by F. So C is 3 into 10 power 8 meters per second by 3 into 10 power 9 gigahertz. So 0.1 meters. Lambda is equal to 0.1 meters. So if you substitute the values, PR is equal to DZT 30 dB. So 30 is equal to 10 log base 10 directive gain. So 10 cube. DZ is equal to 10 cube. So DZT and DZR both are same. So this is equal to 10 cube. This is also equal to 10 cube values. So 10 cube into 10 cube, 10 power 6 into lambda 0.1 by 4 pi into R. R is 1 kilometer. That is nothing but 10 cube whole square into power transmitted. Power transmitted is 1 watt. So this is equal to 10 cube whole square is 10 power 6. So 10 power 6 cancels out. So this is nothing but 0.1 whole square by 4 pi whole square. 0.1 whole square by 4 pi whole square. So if you simplify this, you will get 63 point approximately 32 microwatts. 63.32 microwatts. So if you observe the answers, the approximate value is option C. Which is 63.4 microwatts. So option C is the correct one. So here also, in this problem also, directly we are using the Friis transmission equation to calculate the power received. So this kind of problems are important. We can expect in the examination this type of questions.